So now let's look at inequalities involving absolute values. So just like with absolute value equations, the goal is going to be to isolate the absolute value on one side of the inequality. And there's a few different things that can happen. You're either going to get the absolute value less than or the absolute value greater than some constant c. So for the moment, we're going to assume that c is positive. And it could also be less than or equal or greater than or equal, but we'll look at the strict inequalities for now. If the absolute value of x is less than a positive constant, that means that x is both smaller than c and larger than negative c. So here's c, negative c, and the stuff with the absolute value of x less than c is all of this in between those two constants. So again, this means that x is smaller than c and x is bigger than negative c. In other words, we have the interval from negative c to c. And of course, if we had a less than or equal here, this would be less than or equal, greater than or equal, and we would have square brackets on the ends to show that endpoints are included. Another possibility is that you get the absolute value of x is greater than a constant, and that constant is positive. So when does this happen? The absolute value of x is greater than this constant whenever x is either greater than the constant c or x is less than the constant negative c. And we use open parens to show that the endpoints are not included. So these are all the values for x where x is less than negative c or x is greater than c. And in interval notation, this is, of course, the interval from negative infinity to negative c union the interval from c to infinity. Those are our two major cases. It's also possible that you could end up with your absolute value being less than a constant that is negative, and of course the absolute value less than a negative would mean that the absolute value itself is negative, in which case you have no solutions. And if the absolute value is greater than a constant, and that constant is negative, well, the absolute value is always positive, so it's always greater than negatives, and the solutions consist of all real numbers. So let's look at some examples. Say we have the absolute value of 2x minus 5 is greater than 3. Now, in this case, the absolute value is already solved for. So we can go ahead and split this into two inequalities. Now, we have our absolute value greater than a positive number, so that means that either 2x minus 5, being the argument of the absolute value, is greater than this constant, or 2x minus 5 could be less than the opposite of that constant. And then we just solve both those inequalities. So just remember the things you are allowed to do in an inequality in order to try to isolate a variable or an absolute value. You can add or subtract any constant on both sides of the inequality. You can multiply and divide on both sides of the inequality by any non-zero constant. However, if you multiply or divide by a negative, it changes the direction of your inequality. So here I would start by adding 5 to both sides. 2x is greater than 8. Addition never changes the direction of the inequality. Then I divide both sides by the positive number 2 to get that x is greater than 4. Over here, adding 5 to both sides gives us 2x is less than 2, and dividing both sides by 2 says that x is less than 1. So we have all of the x that are either greater than 4 or less than 1. So on the number line, We want all of the stuff that's greater than 4 or less than 1. And it's a strictly less than, strictly greater than, so we don't include the endpoints. So what that gives us is the interval from negative infinity to 1 union with the interval from 4 to infinity. What if our absolute value is not already solved for? So say we have x minus 2 absolute value plus 2 is less than or equal to 3. So first we solve for the absolute value. We do that by subtracting 2 on both sides of the inequality. So we end up with the absolute value of x minus 2 is less than or equal to 1. So that means that since the absolute value of x minus 2 is less than or equal to 1, we know that the argument of the absolute value, x minus 2, has to be both less than or equal to 1 and greater than or equal to negative 1. So we solve each of those inequalities and we see that x is greater than or equal to, adding 2 on both sides, 1, and x is also less than or equal to 3. So we've got all this stuff that's bigger than 1 and smaller than 3. So we've got all of this stuff in here, and we use square brackets because these are less than or equals and greater than or equals, so the endpoints are included. And in interval notation, this is the interval from 1 to 3, and that is the solution to this inequality. Another example, say we have negative 2 times the absolute value of x minus 4 is greater than 6. So we want to start by solving for the absolute value. So we're going to add 4 on both sides, and that gives us negative 2 absolute value x is greater than 10. And now we're going to divide both sides by negative 2. So we get an absolute value of x on the left and a negative 5 on the right, but I divided out a negative from both sides of an inequality, which turns around the inequality symbol. So it goes from negative 2 times the absolute value of x is greater than 10 to the absolute value of x is less than negative 5. But if the absolute value of x is less than negative 5, see, now we're in the situation where an absolute value is smaller than a negative, which would mean that the absolute value itself is negative, which means that this inequality has no solutions to it. Similarly, if I just looked at the exact same inequality, but with the inequality symbol reversed, so negative 2 times the absolute value of x minus 4 is less than 6, we see that we get negative 2 absolute value of x is less than 10, or the absolute value of x is now dividing by a negative, turns the absolute value symbol around, and the absolute value of x is greater than negative 5. But this is true for all real numbers, so our solution set is just the set of all real numbers R. So there's a short breakdown on how to deal with inequalities that contain absolute values and some of the situations that can arise when you're dealing with such inequalities.